Okay, good morning, everyone. Today we are going to look at VLANs. And previously in network communication, you have looked at the basic of VLAN. It's basically grouping devices together, and they are in the same subnet, and they all share the same switch. But different VLANs are considered as different subnets. So hope you remember that. So these are the objectives that we are going to look at today. We're going to basically look at VLAN segmentation, how do you divide VLAN, how do you implement VLAN configurations and verification. And then we're also going to look at inter-VLAN routing. If you remember from network communications before, if you want to send a packet from a PC in one VLAN to a PC in a different VLAN, you have to use routing, which is inter-VLAN routing. And we are going to look at the different options or usage of how you can actually configure inter-VLAN. So let's look at a little bit of an overview. So what VLAN does is that it segments LAN devices without regard for the physical location of the user or device. So let's look at this figure over here. You would see that, first floor, second floor, third floor. And these PCs, these devices, although they are in different physical floors, they are logically connected together in the same subnet because they are all within the same VLAN. So these 3 PCs or 6 PCs, if you want, all of these devices are within the same VLAN. And they can communicate like they are physically in the same place, although they are all connected to a different switch. So this PC can connect to this PC, communicate, no problem, just go through the switch. Same goes for the other VLANs as well. But this PC, for example, cannot talk to this one without the use of the router, without the help of routing. That is inter-VLAN routing. So VLANs are mutually isolated and packets can only pass between VLANs via a router. So VLANs are logical partition. Logical partition means they are in a group, but actually physically they are apart. One is in first floor, the other one is in second floor, and the other one maybe in third floor. But logically they are put together in the same VLAN. So multiple partitions can be created and multiple VLANs can coexist. So if you remember this particular switch, we have to configure it so that some of the ports are in VLAN 1, VLAN 10, in this case, sorry, VLAN 2 or IT VLAN, and some of the ports are for VLAN HR, VLAN 3, and some of the ports are for VLAN 4. So when PCs are, go into the, let's say, third floor office, and you say, oh, you are HR, so you just plug that PC or the network cable into the ports that are assigned to VLAN HR. That way he is automatically in this group. And the one thing about this is that if you remember that before this, if these are all in one LAN, there is no virtual LAN. So this whole big thing here is one big broadcast domain. So everything that's one person broadcasts, everybody gets it. But once you divide or you group people into VLANs, so when this person, for example, broadcasts something, only the devices within that VLAN gets the broadcast. The people in other VLANs do not get it. So this way, you have sort of like made the size of the broadcast domain smaller. And the smaller the size of the broadcast domain, the smaller the possibility of a broadcast storm. Because a broadcast storm is basically when you have everybody just sending broadcast and broadcast and broadcast, and nobody is actually sending any data. So no work is being done except handling broadcasts. So these people, although they are these devices over here, although they are attached to the same switches, they don't know should I say that they don't know about the other VLANs. They know about their VLANs. Okay. So that is basics of VLAN. Now, placing devices into various VLANs, we have this, you provide segmentation. Okay, so there you go. I put you in IT and then you in HR. So we are segmenting, we are grouping devices together. And because of this grouping, you can do a lot more things. For example, you have better management. Like if this is the lecturer VLAN, for example, and this is the student VLAN, and you want to put up like access control list and security policy, so you can actually apply it to the different groups of the different VLANs. Broadcast, multicast, and unicast are isolated in the individual VLAN, and VLAN is sort of like its own subnet. This is one subnet, this is one subnet, this is one subnet. So when I say subnet, I mean they all are within the same subnet. They have the same network address and the broadcast address, and then they use, the gateway, the same gateway everyone here. And of course, smaller broadcast domain when we segment the different devices into VLANs. So I'm just going to run through this because I've already explained this. Smaller broadcast domains. Okay, so we reduce the number of broadcast domains, lesser possibility of broadcast storm, improve security because according to the VLANs, you can set the security policies, the access control, and everything else. Improve the IT efficiency. So for example, if you are in HR and you are in level 2 and then you are going to be moved to a different department in a different level, we just plug you into the VLAN and then you get the IP address for that VLAN and then you are in a different group. So it's very, very efficient. It's reduced costs, okay, so that it's easier for people to go through different groups and it's easier to support multiple groups in one switch. It has better performance and simpler management. Now, VLANs has many types. There is the default VLAN. Default VLAN is you buy a switch, there is a default VLAN. If you don't configure VLAN for it, there is a default VLAN. And the default VLAN is usually VLAN 1. And all the interfaces, all the interfaces in the switch, if there is 24, 24 lah, if there is 48 interface, 48 lah, all of them will be in VLAN. Okay, so one thing that to remember is that because it is in VLAN 1 is the default, it is always good to change the VLAN name. You cannot change default one, but you have to change, for example, from VLAN 1 to VLAN something else. Same goes, let's say when you buy a device, let's say a router or a server or whatever it is, it comes with the admin ID to be username admin, password admin. The first thing you need to do is change that. If you don't change it, because it is in the white paper, it is in the documentation of the device, hackers can actually use that information and to try to get into your system. So default VLAN, we have data VLAN to manage and transfer data. Native VLAN for those workings that doesn't have a tag. Okay, and then we have management VLAN for management, and also we have voice. So default VLAN, okay, VLAN 1 is following it is the default VLAN, it is the default native VLAN, it is the default management VLAN. You cannot delete VLAN 1, you cannot rename VLAN 1. It's there. You cannot suddenly, oh, VLAN 1, the name is not nice, I'm going to give it VLAN 11. You cannot do that. It will still be VLAN 1. So while we cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLANs. So VLAN 80, VLAN 99, VLAN 1000, it can be changed. Data VLANs are commonly created for specific groups of users or devices. They carry user-generated traffic. So a VLAN carrying voice and management traffic would not be data VLAN. That would be for management traffic is management VLAN, for voice traffic is voice VLAN. Okay, why do we need a different for voice? Isn't it data as well? We will look at that in a little bit. Native VLAN, this is the VLAN that carries all untagged traffic. Now in VLAN, because you are spread, the devices of the same VLAN is spread physically in, like just now, in different stories of the building. So you have to be able to tag the packet so that you know that when you are sending it, oh, this one belongs to VLAN 10, this one is going to VLAN 20. So you know that. So these packets will be tagged. Now, native VLAN, it handles untagged traffic. For example, management traffic is untagged. So you have native VLAN. And this is used for trunk links. I'm talking a lot of stuff that you don't understand yet. It's okay. This is just a bit of sort of like introduction. And later on, we will see what is a trunk link, what does it do, how do we configure a trunk link, and so on. So all frames data VLAN data frames are tagged with the 802.1q protocol. So you will see a lot of .1q. This is what it means, 802.1q.
Can I go to washroom?
You can go anywhere you like because the class is going on.
Okay.
Okay. So all frames are tagged on an 802.1q trunk link except for those on the native VLAN. Okay. The native VLAN is VLAN 1 by default. Management VLAN, the name is management VLAN, it carries network management traffic like SSH, SNMP, syslog. When you log into, virtual terminal, when you log into your system, you put in a username and password. Those things have to be carried and checked, and those things are management VLAN. Okay, and management VLANs are not tagged. Voice VLAN, the reason it is kept separate is because in order to maintain a certain quality of service for voice, they have a different VLAN, okay? And because of this, they would set extra things for that voice VLAN. For example, it would have assured bandwidth because you don't want voice to on and off, on and off. So they would have assured bandwidth. It would have a delay less than 150 milliseconds across the network to ensure voice quality. It would have transmission priority over the other types of network traffic. And it is also be able to be routed around congested areas of the network. So basically, if you have a voice VLAN in Cisco switches, what it does is that it gives it a higher priority so that you have a better quality of service. Okay, so if you see here, we have the IP phone here, right? And then this PC is connected to it, and then these are connected to the switch. Now what happens here is that the switch here, it would know the different VLAN. If it gets a packet for VLAN 20, it will pass it to the PC or to VLAN 20. PC is in VLAN 20. If it gets a voice, which is VLAN 150, it will send it to the IP phone. Actually, within the IP phone, it has a little bit of a switching, excuse me, within the IP phone, it has a little bit of a switching process as well. We'll look at that in a little bit. Okay. So that's the VLAN overview. So let's look at VLANs in a multi-switch environment. VLAN in one switch is easy, but VLAN in a multi-switch environment. So for example, this switch over here, it has 3 VLANs attached to it, 3 different VLANs. And then you have another switch over here, which also has 3 different. So in VLANs, this PC1 can talk to PC4 easily because they are in the same VLAN. But logically thinking, they must have a road, and that's where we have a trunk. So a trunk is a point-to-point link between 2 network devices. For example, here, this PC to this switch, this is what you call an access link. Okay, access link. And between this switch and this switch, this link over here, you have to set it to be a trunk link. This one over here, this is also set to a trunk. Why is this an access and this is trunk? Access basically means I am communicating with other PCs, but I know my VLAN, the thing, I'm going to send it here, and then the switch is going to do its stuff. trunk is basically, you can imagine it to be like a delivery truck, and it sends all of the different VLANs. It carries all of the different VLANs. Okay, it carries the different VLAN here, and then when it comes over here, it will sort the VLAN to its appropriate VLAN. For example, this VLAN 20 wants to send something to this PC5, so it will send over here.
Ito
It will
pintu.
carry. Yes. Was there a question? I guess not. Okay, let's say PC1 is sending something to PC4. At the same time, PC2 is sending something to PC5. So when the packet or the frame travels, okay, here they are tagged. Oh, you are frame, you are VLAN 10 or you are VLAN 20, and then they will travel together. It's not a problem here because they're tagged. Come here, and then it was, oh, you're going to go through here. It will send it there, and then here they will travel together in the trunk link as well. When it comes here, S3 goes up, oh, VLAN 10 goes here, VLAN 20 goes here. Okay, so Cisco trunk functions include, it will allow more than one VLAN, meaning here in the trunk, more than one VLAN can travel on it. It extends the VLAN across the entire network. So if you have extra bits over there, you can have VLANs over there as well. By default, it supports all VLAN. By default, it supports all VLAN, but you can set it to not allow certain VLANs to cross it. For example, if I set here and I say it only allows VLAN 20 and 30, packets from VLAN 10 cannot cross here. But by default, it supports all VLAN. And it supports 802.1q trunking, because in trunk, you have to have tagging, and tagging is given in this protocol. Okay. This is the same thing basically. You have the different VLANs, and then here you have the trunk link. If you notice, here the VLAN trunks are set to support 10, 20, 30, and VLAN 99. VLAN 99 here is set as native. See that? VLAN 99, management and native. So it is set that. So this one, it has been configured so that it can allow all of this VLAN to traverse the trunk. So without VLANs, as I said just now, without VLAN, this whole thing is one big broadcast domain. If this one is sending a broadcast, everybody gets it. But what VLAN does is that it groups everybody so that only within the group that the broadcast will run. Okay, it will limit the broadcast traffic. So just now, everybody here, look at the IP address, all of them are in the same subnet. So everybody will get the broadcast. With VLAN, they are now in different subnets. So when this particular PC4 sends a broadcast, only those devices in VLAN 10 will get the broadcast. Of course, the switches will forward the broadcast, but it will only forward it to devices of the same VLAN. PC2, who is in VLAN 20, will not get the broadcast. Okay, this is the same thing. This is also the same thing that I just explained just now. Okay, now this is tagging. How does tagging happen? You have the Ethernet frame over here, destination MAC, source MAC address, type, length, data, frame check sequence. With the 802.1q, what happens here is that it will attach a tag in the middle of this. You see that? There will be a tag. Okay, so the tag is a process of adding a VLAN identification header to the frame. And it is used to properly transmit multiple VLAN frames through the trunk link. So there will be the type, the priority. Let's look at this one. It will be the type. Okay, this is the 2-bit hexadecimal, and this is referred to as the tag protocol ID here. And then you have the priority, and then you have the canonical format identifier. This one is to allow token ring frames to travel across Ethernet connection. Okay, and then we have the VLAN ID. So, that's how it knows, oh, you belong to VLAN 10, you belong to VLAN 20, and so on, by looking at the VLAN ID. So once you add the tag here, logically, the original frame check sequence will be different because you added something to it. Now, of course, you have to recalculate the frame check sequence for the travel in the trunk link. When it gets to the other end of the trunk, it will take this out, calculate again, and then check with that old frame check sequence. There you go, same thing. So native VLANs and 802.1q tagging. So tagging is typically done in all VLANs. The use of native VLAN was designed for legacy use because hubs cannot handle tagging. So if there are networks who are using hub, then they will go under the native one, so they doesn't need any tagging. So, and let's change VLAN 1 is the native VLAN. One thing about trunk is that both ends of the trunk must be configured with the same native VLAN. For example, if this is the trunk and this is the trunk, and if here is native VLAN is configured as VLAN 99, here also must be VLAN 99, so that they can actually understand each other. So if you configure it not parallel, in the sense that this is configured as native VLAN as VLAN 99, here native VLAN is VLAN 100, then you would have a problem in connectivity. Okay, so each trunk is configured separately, so it is possible to have different native VLANs. So you, the network manager who is configuring the trunk and the VLANs, you must be aware of what you are doing. So control traffic sent to the native VLAN should not be tagged. Frames received untagged remain untagged and are placed in the native VLAN when forwarded. Now, if there are no ports associated to the native VLAN and no other trunk links, an untagged frame is dropped. Basically, it's this. If you configure all the VLANs, you configured your trunk, but you forgot to configure a native VLAN, any untagged frame is dropped. Because in a trunk, it handles tagged frames, and it puts in native native VLAN there to handle the untagged frames. So if you forgot to do that, then all of the untagged frames will be dropped. So when configuring a switch port on a Cisco switch, configure devices so that they do not send tagged frames on the native VLAN. Tagged frames are sent on the data VLAN. Untagged frames are sent on the native VLAN. So remember just now that I said within the voice, the IP phone, there is its own switching thing. So it has that. The link between the switch and the IP phone here behaves like a trunk to carry traffic, both the data traffic and also the voice traffic, to the different VLANs over here. So here it has 3 ports within the Cisco IP phone. It has 3 ports here. You have P1, P2, and P3. P1 connects to the switch or other VoIP devices. P2, this carries the IP phone traffic, meaning the call. Okay, and then here is the access port that connects to the PC or other device. So when there is a frame coming here and it is assigned to VLAN 20, which is this VLAN, if you remember, and then it will send it through P3 to the access port to the device. If it comes and it is tagged with VLAN 150 for the voice, then it will be sent to P. And then when you get information from the device, it will send through here. Same goes for that. In your labs, there will be an example about how to use voice. Some of the things you see there is not part of the course. I'll show you in a little bit what I mean. Okay. Oh, this one I just explained just now. So to show VLAN interfaces FA0, this is the interface that we want to see, because of if you write show interfaces FA0/18, it will show you a lot of information. But when we say switchboard, it will only show you information regarding switchboards. Okay, so we have here access mode LAN. So this particular interface belongs to this VLAN, and this VLAN has a name, and the name is student. This particular interface is also connected to this VLAN, which is the voice VLAN. So that particular interface in the switch has that. Okay, so you have all the other information here. You see administrative mode is static access because you set the interface to be an access mode interface. Okay, and then operational trunking encapsulation is native. Don't worry about that. I'll talk to you about trunking in a little bit. Okay, we have seen, that one, a switch can be divided into different VLANs. Two, devices have to be in a certain VLAN. All devices in the same VLAN are in the same subnet. So their IP addresses have to be within the same subnet. And to carry information or packets from one VLAN to another, the same VLAN, but they are in a physically different switches, then you have to have trunk configured. Then we have the voice VLAN, and then we have data VLAN. So now we are going to take that information and we're going to try and implement a VLAN. Okay. So first thing to do is to know that there are two categories of VLAN. One is a normal range VLAN, and you know the normal range VLAN by the numbers. VLAN numbers from 1 to 1005, these are considered normal range VLANs. Okay, and these are stored in the VLAN.dat in the flash memory. So this happened before in lab. Okay, there was a student, they were configuring a switch, right? And then, the switch, I don't know why they decided to change switches. What they did was they sort of like took the flash part from one switch and then they just switched it to another one. So, but then they forgot whatever they did and they deleted that, and all the VLAN information is gone as well. So good for you to know where information is being stored. Okay, so ID here, if you look at show VLAN brief, this one is VLAN 1. You cannot delete, you cannot rename, but there is also the 1002 until 1005. This has been reserved. You don't configure this. Once you have, you just open a switch and type show VLAN brief, you will see this. This is already done. Okay, so these are all automatically created. They cannot be removed. They cannot be recreated. Okay, they will be automatically created. Now, extended range VLANs are VLANs from 1006 to 4096, more than the normal. And then they are stored in the NVRAM. So the difference here is that the VLAN trunking protocol does not learn about the extended range VLAN. It only learns about the normal range. Okay, you will learn about the BTP later on, I think, in internet work. So just know this for the sake. So for our class, we will be using this one. Okay. So this is the difference between the normal range VLAN and the extended range VLAN. So used in small and medium-sized businesses, used by service providers, and then the reserve one where it is stored, and BTP can synchronize this one. BTP doesn't by default synchronize it, or you have to configure. So these are the difference between normal range and extended range. Okay. Now, before you do anything, before you put a PC into a VLAN, you have to have a VLAN. So you have to create a VLAN. Okay, so how do you create a VLAN? You go into the global configuration mode and you type VLAN ID, VLAN 20, VLAN 15. VLAN 100. And then you give the VLAN a name. Now, it is good to give it a name that you understand so that you can manage your network better. If you don't, the switch will give it a name, VLAN, VLAN 0020, for example. But you can give it a good name, like say VLAN 20 and then name student. So we know that VLAN 20 belongs to the student VLAN. Okay, and then and we are already done. We have configured ourselves a VLAN. So here in the switch, this switch we have configured one VLAN, which is VLAN 20, which is the student VLAN. Is this student PC in the VLAN yet? Not yet. We have created the name of the group, but we haven't assigned the members to the group. So now we have to assign a member to the group by assigning the port. So we are assigning this member, port 018 here, to this group. So go into the global configuration mode, and then you have interface, whatever the interface was. Just now it was fast Ethernet 0/18. We have to say that your work or this interface will be the access mode. Okay, it will run in the access mode. So switch port, mode, access. And then we assign it to the VLAN. Switch port, access, this port here is going to be assigned to VLAN, let's say VLAN 20 or VLAN 30, and then it will be assigned. Now, this particular information here, if you don't put it, it will still work. If you have all the others, it will still work. But it is good for you to set what mode that particular interface is going to be. Because you would have access, you would have trunk, or you would have negotiate. So negotiate is, while it is there, it is not advisable. We will see a little bit later. Okay, but for now, I would say it is best practice to give it its mode. So in this case, we say switch port mode access, and then we assign that access mode to the VLAN. So in this case here, this particular interface, switch port mode access, switch port access VLAN 20. And now this interface is part of the VLAN 20. This PC is part of VLAN 20, and then you give it the IP address that is the subnet for that VLAN, and in this case is 172.17.20. Create the VLAN, assign the members to the VLAN, and then when you plug this PC to this interface, which is the member, that PC is now in that VLAN. Sorry about that. Are we okay so far? Okay. So if you see here, this is also configuration VLAN 20. We are creating the VLAN. We give the VLAN a name, and then VLAN 150, we create the voice VLAN, give it a name, and then we assign that interface. Just now we have assigned it to VLAN 20. We can now assign it to the voice VLAN as well. The switch port voice, now it is voice, and it is assigned to the member of 150. And it has these things, okay? It is beyond the scope of our course, okay? But we just follow that one for a bit. So it would tell you about whether it's trust, the cost of service, okay? And the device IP phone, IP precedence, and so on. Forget about that for a second. Just follow. So what we have done here is that for interface fast Ethernet, here we have grouped it into two VLANs, which is the student VLAN and the voice VLAN. Now, can we do this? Can we group an interface to student VLAN and staff VLAN, which both are data VLANs? Can we do that? Actually, you cannot. But you can try later. Configure it to one data VLAN and then configure it to another data VLAN. And it's not going to work, okay? So there you go. We have created that. This one here, where we have two, works because both of them are attached to the same interface in the switch. So data comes in, the phone will do some switching, and then, voices it will take, data it will send it to the appropriate VLAN. Now that you have created a VLAN, right, and then you don't want it, you put a port as a member of a VLAN, you want to change the member, you want to change the membership, you can just type no switch port access VLAN under the interface, and you would see we have that VLAN. Previously, fast Ethernet 018 was here, but because we say no switch port access VLAN, we don't want to be in that group anymore. It went back to the default VLAN. Okay. Another thing is to delete the VLAN. Let's say you have like many VLANs and you want to delete the VLAN. Now, one thing you can, to delete a VLAN, just say no VLAN ID. What happens is that that VLAN is not there anymore. But one thing to remember is before you delete a VLAN, reassign the interfaces that were members of those VLANs first. Okay, if I'm going to take this as an example of you register for a class, let's say computer network, and then section 4. And then suddenly, oh, we are closing section 4, and I just close section 4. What happens to the student who already assigned to section 4? They will be inactive. They don't have any class, right? So before we close the section 4, first we reassign all of the students, whether to the default VLAN or to other VLAN, section 1 or section 2 or whatever it is. Then only we close section 4. Okay, logic, right? So that's how it works. So before you do the no VLAN thing, make sure that one, there is no interface, there's no member in that VLAN. If there is a member, reassign them first, then only do the no VLAN ID here. Okay. You can also delete the entire VLAN.dat file with the delete flash VLAN.dat. Okay, and then you reload it, and then you won't have the VLAN information anymore. It will go back, revert to the default. Okay. So after you have configured, of course, you have to verify. So you can type, for example, show VLAN. Show VLAN will show you all VLANs, but if you say show VLAN name student, then it will show you information about that particular VLAN, which is VLAN student, the status is active, the ports that are assigned to it. Okay. Show VLAN summary will show you all of the different VLANs that this switch has. In this case, it has 7. Okay. Then show interface VLAN 20, it will show you interfaces of the VLAN and all the other information, and you can see whether or not the VLAN is up. So show VLAN, you can have show VLAN brief. It will show you the brief information, status, ports, 1 VLAN per line. If you can type show VLAN ID like show VLAN ID 20, okay, then it will show you information about the identified VLAN ID number. If you go by name, then it will show you the name, the information by the name. Just now we saw VLAN student, right? This is by name. Or you can have VLAN summary to see all of the existing. Okay, that is implementation. Is configuration of implementation of VLAN easy? Yes. You first create the group, then you assign the members, right? And then if you decide you don't want that member to be in their group anymore, take them out. If you think that the group is not relevant anymore, check that there are members. If they are, take the members, reassign them, and then close or delete that group. Easy peasy, lemon squeezy. So now that we know on a switch that we created a VLAN, we assigned the ports within that VLAN, different VLANs, we'll talk about VLAN trunks. Now, a VLAN trunk is a layer 2 link between two switches that carries traffics for all VLANs. Okay. Again, by default, it carries for everyone, but if you decide not to allow certain VLANs, it will not allow those. Okay. So to enable trunk links, you configure the ports on either end of the physical link with parallel sets of commands. So this end and this end, you configure it the same. Meaning, if this one here has native VLAN 99, this one also must have native VLAN 99. If this one is talking about VLAN 10, 20, and 30, don't call it some other VLANs on this side if it corresponds to the same group. Okay. Sometimes trunk ports are also called tagged ports due to addition of tagging. And how does trunk do that? With the 802.1q protocol. Okay, let's look at this topology. So there are 4 VLANs, 10, 20, 30, and 99. And this is the trunk that is going to be used to carry these different VLANs to the other VLANs in the other switches, okay? So how do we configure a trunk? Configure terminal, the interface that is going to be the trunk, in this case, fast Ethernet 01 on both, okay? So fast Ethernet 01, switch port mode trunk. Remember just now when we assigned the member to the VLAN, we said it is mode access. Mode access means it can carry data VLAN. Mode trunk, it can carry different VLAN as well, okay? So we set this particular IP to be a permanent trunking mode, mode trunk. Then, excuse me, switch port trunk native VLAN and then the VLAN ID. So set the native VLAN to something other than VLAN 1. This is also for security reason. Switch port trunk allowed VLAN. These are the VLAN IDs that you are going to allow to go through the trunk. Okay, and then here, interface, this is in switch 1 over here. Interface fast Ethernet 01, this interface. Switch port mode trunk, this interface is now working as a trunk. Trunk native VLAN is 99, same as this one. This one is also 99. And then trunk allowed VLAN. This is the list of allowed VLANs, 10, 20, 30, 99. 10, 20, 30, 99. Let's say I forget 30. I put 10, 20, 99. Then the 30 cannot travel the trunk. Okay, so be very careful about it. So note the native VLAN must be the same on both ends of the trunk, else the trunk would not. So why native VLAN? It was created for backward compatibility with old devices, such as hubs that do not support VLANs. It is used by the switch to carry specific control and management protocol like the CDP, the VTP, the STP, and so on. So control traffic doesn't need any VLAN tagging to cross over the trunk. So it is useful when dealing with voice over IP. And again, native VLAN does not need a tag in the trunk. That's why we have that native VLAN. So to reset, okay, see with this interface, we don't want to allow these VLANs anymore. We don't want this. So we can say no switch port trunk allowed. So whatever we did before the 10, 20, 30, we can delete that. Just put the no in front. But one thing, when you do this, check to see show interfaces fast Ethernet 01, you see that the mode is still trunk. Remember the switch port mode trunk that we set? It sets the, the interface to be a trunk interface. Okay, it's still that. Even though now the VLAN 1 is default, is enable, all, everything is back to it except for that it's still the mode trunk. And of course, because it is mode trunk, it can understand and look for the .1q protocol, 802.1q. So if you want it to stop being a trunk, you have to change it back to switch port mode access. So now it will be access. Okay, static mode access. Although the trunk here is .1q, it doesn't mean that it will be tagged, yes, of course, but it is not a trunk anymore. It is now an access mode. So it cannot handle. So you can verify here, Switch port mode trunk, switch port trunk native VLAN 99. You can verify it with the show interface of that particular interface and switch port. So it gives you sort of like a filtered output. So yep, it is trunk. Encapsulation is .1Q. Oh, trunking native VLAN is VLAN 99. Ta-da, over there. Okay. And then tagging is enabled. Trunk VLANs enabled all. By default, all is enabled. But if you use the allowed, you can allow certain trunks to go through. Sorry, certain VLANs to go through. Now, we looked at configurations of VLAN, VLAN membership. We looked at trunk, right? Now we're going to look at troubleshooting. At the end of the day, the problem with VLANs come from us configuring things incorrectly. Okay, from whether or not we do subnetting incorrectly, or we forget about allowing certain VLANs, or we want it to be VLAN 10, but we somehow typed an extra 0 and it became VLAN 100. So it's mostly configuration. Okay, so let's look at a few issues. One is IP addressing issues. Now, I said just now that a VLAN is a subnet. All devices in the same VLAN are in the same subnet. So their IP addresses must match, right? If you are in a LAN and you have suddenly a different IP address, you're not going to be working in that VLAN, that LAN. So same goes with VLAN. So here, this PC1 is in VLAN 10. The server is in VLAN 10 as well. But look at the IP address, 172.172.10.21, 172.17, 10.30. Somehow it have an extra bit of 2 there. So now they are not in the same subnet anymore. Okay, so then we would have a problem. If you are in the same VLAN, you must be in the same subnet. So you just change the IP address, whichever is the correct IP address. If 17, change this one, and then you would have no problems anymore. If the problem is IP address. Okay? I have a feeling that I'm doing this really fast. Are you guys following this? Oh, good then. All right. So missing VLANs. Missing VLANs are when you forget to create a VLAN or you forget to allow a VLAN. So if all the IP address mismatches have been solved, but the device still cannot connect, check if the VLAN exists. Switch. How do you check? Show VLAN, show MAC address table, show interfaces, switch port. So you can say, is the port in correct VLAN? Yes. Okay. No problem. And is the VLAN present in the VLAN database? Yes. Then we have no problem. But let's say no, then you have to create that VLAN. If the port is in a wrong VLAN, then reassign the port to the correct VLAN. Now here, in this example, if you start show interfaces for the Ethernet, switch port, and it says access mode VLAN 10 inactive, what happens here is this particular interface has been assigned to VLAN 10, but somebody deleted VLAN 10. So it is now an inactive VLAN. So this is what happens when you delete a VLAN without reassigning its members. Okay, so this interface has to be reassigned to either the default VLAN or a new VLAN. Inactive here because VLAN 10 was removed from the switch. So this is another problem where this is in trunks. For example, here, native VLAN is 2. So if we have been using native VLAN is VLAN 99, but for this particular switch, SW1 and interface for the trunk, we configured VLAN 2 to be the native VLAN, then we would have a problem. And to change this, we just have to change it to the same VLAN on both sides. It looks simple, right? But sometimes these are little things that we are not particularly focusing on, and then it makes our VLAN doesn't work. Okay? So troubleshoot trunks, native VLAN on local and pure ports match. If no, change the native VLAN to match. If it matches and still we have a problem, trunk modes on local and pure ports compatible. Compatible, we will look at this in a little bit. This is the mode, okay? Mode means we set one trunk to be trunk and the other trunk to be access. We have a problem. Trunk can talk to trunk, or trunk can talk with the other side being negotiable. We will look at negotiation in a little bit, okay? But both end of the trunk must be compatible for it to work. Okay. Common problems with trunks. Trunking issues are usually associated with incorrect configurations. So the most common type of trunk configurations errors are native VLAN mismatches, trunk mode mismatches, and allowed VLANs on trunks, which is we forgot to allow a certain VLAN. So when a trunk problem is suspected, it is recommended to troubleshoot in order shown above. Check your native VLAN first. If it's okay, look at the modes. If it's okay, look at the allow. So this is an example of incorrect port. Okay, so here PC4 cannot reach the web server. Shouldn't be a problem because they are in the same VLAN, right? And then here it has allowed 10 and 99, meaning VLAN 10 is allowed and VLAN native VLAN 99 is set. And it seems that all of them are set the same. So the trunk links S1 and S3 is verified, and then it shows that one is an access. Okay, here in S1, which is this one, you say show interfaces trunk. So it says F01 is a trunk, F01 is a trunk, okay, and then the native VLAN there is 99, okay, and the allowed VLAN is 10 and 99, okay, and then interface F fast Ethernet 03, okay, and it is a trunk. Okay, good. So we know that this is a trunk and this is a trunk. Then we go and check at switch 3, show interfaces fast Ethernet 03. We find that the mode is access. So in this link over here, which is supposed to be a trunk link, this side is trunk, this side is access. So problem. What we can do is go back to S3, go back to fast Ethernet 03, and change the mode from access to trunk. See, very simple thing. Switch port mode access, switch port mode trunk. One little mistake, and we have connectivity issues. Again, this one is showing what is allowed. Okay, so this is VLAN 20. It cannot go to the email server over here. Okay, the trunk, everything is a trunk is okay, but the allowed VLANs, okay, in S1, look at that, the allowed VLAN is 10 and 99 on both the trunk interfaces, 10, 99, 10, 99. So it doesn't allow packets for VLAN 20 to traverse on that trunk. So go in, add VLAN 20 in the allowed list, and then it will be. Now, dynamic trunking protocol. We'll go through dynamic trunking protocol, and then I'll give you 5 minutes of break, and then I think we can finish the inter-VLAN routing today, I think. If not, we will see. So dynamic trunking protocol, remember I said you can go mode trunk, mode access, or negotiate. So this is where the negotiate comes in, okay? So DTP, dynamic trunking protocol, is a proprietary Cisco protocol. That means it only works on Cisco devices, Cisco switches, okay? DTP is on by default on Catalyst 2960 and 2950 switches. Dynamic auto is default, okay? It may be turned off with a non-negotiate command. Switch port, non-negotiate. That means we switch off DTP, okay? Setting a switch to a static trunk or static access will avoid negotiation issues. So it is best for you to say either it is a trunk or it is an access. And we don't let the switch to decide by negotiating. It has that capabilities, but it is best not to let it decide. But let's say we say, okay, fine. So switch port command has additional options. We saw just now switch port mode access, switch port mode trunk. We saw these two already. So there is something called switch port mode dynamic. And within dynamic, there is dynamic auto and dynamic desirable. Dynamic auto, it will become a trunk. This particular interface will become a trunk interface if the neighbor interface, the other end of the cable, is set to trunk or desirable mode. If your interface is set to dynamic desirable, what it does is that it actively seeks to become a trunk by negotiating with the other auto or desirable interfaces. Basically, it means that for an interface, you can set it to be access. It will be an access unconditionally. You can set it to trunk, switchboard mode trunk. Then it will set it to trunk unconditionally. Or you can set it to be switchboard mode dynamic. And under dynamic is either auto or desirable. Okay, so set trunking mode dynamic negotiation parameter to auto. So if it is dynamic, that means you are setting the port to negotiate with the other end of the cable, the switch that is connected to that port. Okay, so how does this work? Here, if you want to check it, administrative mode dynamic auto. That means it is set to negotiate with the other end of the switch. So how does the result of this negotiation comes? So up here is one side of the cable, and this here is the other side of the cable. Let's say this is us and that is them. Okay, if you are on dynamic auto and the other side is also on dynamic auto, then that will be an access link. Both will be set to access. If your side is dynamic auto and the other side is dynamic desirable, then both will be set to trunk. If your side is dynamic auto and the other side is set to trunk, then you will become trunk. If your side is dynamic auto and the other side is access, you will become access. Same goes, if your side is dynamic desirable, the other side is dynamic auto, you will be set to trunk. If your side, you get what I mean. So because you set it to be dynamic, it has a lot of variables. So actually, it is advisable, best practice recommends that the interface be set to either access or trunk and to turn off DTP. Don't use this DTP, okay? Because DTP will set some problem. Best to set whether or not that interface is going to be mode access or mode trunk. We set it. The network manager, the network administrator sets it because you know what that interface is going to do. Yes, there is capability for it to negotiate, but the best thing for you to do is switch off this negotiation. So that is the end of VLAN. So the next thing we're going to look at is inter-VLAN routing. Just now with VLAN trunk, what we did was if all of them are connected by different switches, so we need the trunk link to talk. VLAN 10 to VLAN 10, VLAN 20 to VLAN 20 is intra-VLAN communication. So now it's about inter-VLAN communication. VLAN 10 wants to talk to VLAN 20. So we need a routing capability. So would you like me to continue this? I'll give you a 5-minute break and then we will continue this. Is that okay? So just now we basically understood about creating VLAN, assigning members to VLAN, and then how do we communicate with the same VLAN, but they are physically located in a different switch. We talked about trunks, and we talked about configuration of all this. And we also looked at possible issues that need to be troubleshooted, configuration issues basically. So now we are going to look at inter-VLAN routing. Inter-VLAN routing means how do you get packets between two different VLANs? If a PC, let's say in VLAN 10, wants to communicate with the server in VLAN 20, how does it work? So layer 2 switches, because they are layer 2, they cannot perform any routing capabilities. So to route between different subnets, which is looking at the IP addresses, which is layer 3 addressing. So to do that, you need the help of a router because switches, layer 2 switches cannot do routing. So you need a router. So inter-VLAN routing is a process for forwarding network traffic from one VLAN to another using a router. So if you look here, PC1 is in VLAN 10, PC3 is in VLAN 30. PC1 wants to ping PC3, for example, it has to have the router over there to do the routing. Now, how does inter-VLAN routing works? There are 3 different ways or methods for you to achieve inter-VLAN routing. One is legacy inter-VLAN routing. The name legacy should advise you that it is something used in the olden times. It is not used anymore, but we are teaching you for the purpose of education. Okay, so and then we have router on a stick and also layer 3 switching using SVIs or switching virtual interfaces. So let's look at those 2. So legacy inter-VLAN routing is a legacy solution, doesn't scale well, in fact it's not used anymore. Router on a stick is an acceptable solution for a small to medium-sized network. And layer 3 switch using switched virtual interfaces, this is the most scalable solution for medium to large organizations. But we are going to look at all 3 to have sort of like a basic understanding how it works, what is entailed in it, and how do we configure it. Okay, so this is going to be interesting. So in the past, okay, they looked at inter-VLAN routing in a very simple way. So unique routing will give you a router interface. So if there are 3 VLANs, we'll give you 3 router interfaces. If there are 5 VLANs, we'll give you 5 router interfaces. If you are 12 VLANs, we'll give you 12 router interfaces. Simple enough, right? But the problem is, how many interfaces does the router have? So if you have 12 VLANs and you need 12 router interfaces, how many routers do you need? And you guys, in your project in Netcom before, you looked at the different prices of these devices. Are routers cheap? So to buy a lot more of it is not really good. It doesn't scale very well. Okay. So in the inter-VLAN, legacy inter-VLAN routing, router interfaces were used to route VLANs. Each VLAN was connected to a different physical router interface. Packets would arrive on the router through one interface and be routed and leave through another. Very much like the normal different LANs would do, even though it's VLANs. Okay? Because the router interface were connected to the VLANs and had IP addresses from that specific VLAN, routing between VLANs was achieved. Large networks with large number of VLANs will require many router interfaces, so this doesn't scale well. So if we look here, we have VLAN 10, we have VLAN 30. There are 2 VLANs here. Sorry, there are 3 VLANs here, 10, 20, and 30, right? So here what happens is that if they want to communicate with each other, they would go, let's say PC1 is in F11 is what? VLAN 10, F18 is VLAN 20, okay, 10, 20, and 30. So let's say PC1 wants to talk to PC3, if we go here, go to the trunk, whether it's this trunk or that one, depending on how it's configured, and then it will go to the router. It will go to its PC1's gateway. So 172.17.10.21 will go to this 172.17.10.1. This is its gateway. It will go all the way there. The router will perform routing. Of course, it looks at the routing table. Oh, you're going to 10.30. It will say, oh, it is in the G001, and then it will send it out here. You will go to the switch, go to the trunk, and then get to the PC. Easy enough, right? So, but the problem here is that it has a significant limitation. How many interfaces are you going to be able to give to the different VLANs? If your company is very small and you have 2 VLANs, fine. But what happens if your company is bigger and you have more VLANs? Or the VLANs cover a lot different places, different physical spaces, I mean. So then we have a problem. Legacy inter-VLAN routing is not reasonably scalable because routers have a limited number of physical interfaces, and requiring one physical router interface per VLAN will quickly exhaust the physical interface capacity of a router. Hence, this method, the legacy inter-VLAN method, is no longer implemented. We just want to tell you sort of like the story of how things progressed, okay? If you want to take it that way. So router on a stick is different. It says, why do we need to give every VLAN its own router interface? Why not all the VLANs share the same interface, but we will make sub interfaces. Okay, we will make sub interfaces. So what happens here is that in the router on a stick approach, it uses only one of the router's physical interface, and then it will create logical interfaces on the same interface. It will create logical interfaces for the different sub interfaces. So it will use one physical interface, but within that physical interface, if you notice here, it created sub interfaces. One sub interface for VLAN 10, one sub interface for VLAN 20, one sub interface for VLAN 30, but all of them uses one physical interface, which is the gigabit 0/0. So VLAN members are configured to use the sub interface address as the default gateway. So for VLAN here, this 10.21, it will use 10.1 as its gateway. It's its default gateway. So once you have sub interfaces, when all of the different VLANs come to this physical interface, you will look at the tag to determine which of the sub interface it will use. Okay, so the router on a stick interface VLAN inter-VLAN routing method overcomes the limitation of the legacy inter-VLAN routing. It requires only one physical Ethernet interface to route traffic between multiple VLANs on a network. Yay! We are saving on the physical interface. We don't have to use many routers. So a Cisco iOS router is configured as an 802.1q trunk and connected to a trunk port on a layer 2 switch. So the router is configured as a trunk and connected to a trunk on a layer 2 switch. Specifically, the router interface is configured using sub-interfaces to identify routable VLANs. These sub-interfaces are software-based virtual interfaces. That's why we call it logical. Okay, software-based virtual interfaces. They would have their own IP addresses, okay, and it can be configured, and it will respond to its own VLAN assignment. When VLAN tagged traffic enters the router interface, it is forwarded to the VLAN sub-interface. So if the tag says the VLAN ID is 10, it will be sent to the sub-interface for the VLAN 10 that handles the VLAN 10 traffic. So after a routing decision is made based on the destination IP network address, the router determines the exit interface for the traffic, and then it will be sent out to the destination. Now, one thing about router on a stick is that while it works better, of course, it's way better than the legacy inter-VLAN routing, it doesn't scale very well beyond 50 VLANs. So if you have like virtual VLANs, the sub interfaces, if you have more than 50, it doesn't scale well anymore. Okay? Because imagine if your routing table has 50 lines or 100 lines. it will take a long time for it to go through and find, right? So it doesn't scale very well. If your router can handle a big bag, but it takes a lot of time, then your networking, your connectivity would suffer. You know, your performance of the network will suffer. So it doesn't scale very well when you have more than 50 VLANs. It's smaller than that, 30 VLANs, 20 VLANs, 5 VLANs, 2 VLANs, no problem. Now then we have the inter-VLAN routing with the layer 3 switch. Rather than using a router, what it does is that it uses a layer 3 switch. Now, a layer 3 switch is a switch that has gone to the gym and has very big muscles that it can do routing capabilities. Okay? A layer 3 switch, it can handle layer 2 information and it can also handle layer 3 information. That means it can handle MAC addresses, it can also handle IP addresses. So the modern method of performing inter-VLAN routing is to use layer 3 switches and switch virtual interfaces. An SPI is a virtual interface that is configured on a layer 3 switch. So here, so you can configure an SPI to handle VLAN 10. You can create another one to handle VLAN 20 on the layer 3 switch. Okay. Now, when you read books or articles or even the Netiquette, sometimes they call it multi-layer switch. Same thing, it is the layer 3 switch. It's called multi-layer switch because it can work in layer 2 and in layer 3. But for the sake of here in class, we'll just call it layer 3 switch. So the inter-VLAN SPIs are created the same way the management VLAN interface is configured. Okay, so although it is virtual, you have to create it giving an IP address and the default gateway and so on. And although it's virtual, the SPI performs the same functions for the VLAN as a router interface would. Specifically, it provides layer 3 processing for packets that are sent to and from all switch port associated with that VLAN. So why have a layer 3 switch rather than a router? So these are the advantages. One, it is much faster than router on a stick because everything is hardware switched and routed. Okay, when it is hardware switched, it is faster than if it is software switched. There is no need for external links from the switch to the router for routing. I am a switch, I can handle switch stuff, but because I am, layer 3 as well, I can handle routing stuff. So you don't have to have an extra external link. Latency is much lower because data does not need to leave the switch in order to be routed to a different network. Okay, it can be handled in the same device. It doesn't have to leave that and queue again to transfer. So that latency is cut off. They are more commonly deployed in campus LAN than routers. So you will see a lot of more layer 3 switches in campus LAN than routers. But then again, that is how it is being deployed. But the only disadvantage is that layer 3 switches are more expensive than routers. That's the only advantage. Sorry, the only disadvantage. But if you're willing to pay a little bit more and have faster communication, because hardware switch is faster than software switch, then it is, I think, value for money. Okay. What we're going to do right now is to visit each of this inter-VLAN routing. We're going to learn how it works. We're going to look at how it's configured and then maybe some issues. Okay. So here we know legacy inter-VLAN routing. It would have an individual interface on the router for each of the VLANs. So here we have 2 VLANs. We have 2 physical interface needed on the router. Okay. So first, of course, we have to create the VLAN, assign the the members to the VLAN. So we have created VLAN 10, assigned this 2 interfaces to VLAN 10, created VLAN 30, and assigned these 2 interfaces to VLAN 30. So in switch 1, create VLAN 10, VLAN 30, and then we assign those interfaces. Okay. Then on the router, right, for each of the interface here, G00 is given to VLAN 10, G01 is given to VLAN 30. So we just give it an IP address and a subnet mask that belongs to the subnet of VLAN 10 for G00. The IP address that belongs to the subnet, that is VLAN 30. No shutdown, done. Ta-da, finish. Easy, isn't it? Because we're not doing anything. We are just telling the router to route. That is what routers do. It's just doing its job. So if a router comes like a switch, like many interfaces, maybe the legacy inter VLAN routing will still be there. But unfortunately, it's not very good. Okay, so no. Then we have the inter VLAN routing with router on a stick. Now, router on a stick, that means however many VLANs you have, but when they want to communicate inter VLAN, they only will use one interface on the router. So you would imagine it to be like a lollipop, right? The router is the lollipop and then the stick. So router on a stick. So it is connected to all of the different VLANs. And to create that on one physical interface, we create sub-interfaces for the different VLANs. So here, the interface is G001, G001, and then we create a sub-interface for VLAN 10. And then this is the IP address, and the IP address must match the subnet of VLAN 10. And then this one is VLAN 20, and this one is VLAN 99. Now, notice that 10, 20, 30 here, you don't have to say 10 to become VLAN 10, but it's easier for you to remember when you're looking at all of the verifications to know that. So dot 10 means VLAN 10, then again the sum. Okay. Of course, this one has to be a trunk, this one has to be a trunk. Logical, because these are different VLANs. So a trunk can carry different VLANs traffic. And access cannot do that. It has to be a trunk. So these should be trunk links. Don't forget that. Okay. Now, once you've configured that, you can check it by trying to ping these things, whether or not it can ping. Okay. So to enable devices to ping each other, the switches must be configured with VLANs and trunking, and the router must be configured with inter-VLAN routing. So of course, let's try this. This is the topology. Okay. We have a router connected to S1, and then S1 is connected to S2. In S1, there is VLAN 10. In S2, there is VLAN 20. Of course, there is a VLAN 20 here as well, but for the sake of clearer information, they did it this way. Okay, so this is the topology. So first, create the VLAN 10, VLAN name, assign the interface and so on. So there you go. Create the VLAN name, VLAN 10, and then we assign the members. This is the native VLAN management interface, done. And then we assign the interface, see, to be in the VLAN mode access. And of course, on the switch, don't forget to set the trunk. Here, this is the trunk, this is the trunk. So don't forget to set these two interfaces on S1 as trunks. Okay. Now on the router, you need to configure the sub-interfaces. Okay, so to configure the sub-interface, you have to create the sub-interface. So to create the sub-interface, you use the command interface and then the interface ID. This is the physical interface followed by a dot that signifies after this is the sub-interface and then the sub-interface ID. Sub-interface G001, which is the name of the physical interface, dot, and then the sub. So although not required, it is customary to match the sub-interface number with the VLAN number. It's not required. You can use whatever number you want here. But when you start troubleshooting and verifying, it's easier for you to look at this and say, oh, okay, this is the sub-interface for VLAN 10. Okay, just making it easy for the network administrator. So how do you configure sub-interface? You go into the router, you go into the physical interface that you're going to use, and then add a dot, and then the sub-interface. So each sub-interface is then configured with the following two commands. Encapsulation.1q, we are telling them that, this sub-interface, it will be handling some tagging of VLAN. .1q. That is the IEEE 802.1q. And then the VLAN ID and the native. The native keyword is option, is also appended to set the native VLAN to something other than VLAN. Okay? And then the IP address, and then the IP address and the subnet mask. The subnet address of that particular VLAN to that particular sub interface. Okay. So repeat this. Let me show you how it's done. So this is the physical interface. In the router, the physical interface is G001. Okay. So interface G001.10. Description, default gateway for VLAN 10. And then encapsulation.1q10, because 10 is the VLAN ID, right? So this is the VLAN ID. And then the IP address and the subnet mask. Now remember, this IP address and subnet mask must belong to the subnet of the VLAN 10. Okay, so there, and then interface D001.20. Now we are on the second subinterface, and this we give it a description so that we know this is for VLAN 20. Encapsulation.1q20, this is the VLAN ID, and then the IP address and mask. Do the same thing for the native VLAN as well. Encapsulation.1q99, and then the IP address and the subnet mask. And then the physical interface, just have a description so that you know what it is connected to. This is a trunk link to S1, and don't forget the no shut. Without the no shut, this interface will be inactive. All of this won't work. Okay, sort of like these are the kids. If the mother is not active, the kids will not be active as well. So this is how we create sub-interfaces in a physical interface on the router. Okay, interface dot, the ID here, encapsulation dot 1q, tagging this, that means this particular sub-interface will handle the frames or the packets with the tag with VLAN ID 10 only. That's why it has that there. Okay, and then IP address ends. So once you have configured that, you have configured on the switch side, you have configured the PC, gave it an IP address, and set the sub interface as its default gateway, everything is done. Now you can verify. So one way to verify that is to ping. So try to ping your default gateway from the PC, try to ping the other PC, okay? And it's done. So in this case, we try to ping, everything is fine. So another way to verify aside from ping is to look at the routing table of the router, show IP interface brief, show interfaces, show interface trunk to see whether or not it's set as trunk. And that is how you configure inter-VLAN routing with router on a stick. Okay, so we have that connection, one interface of the router to the switch. On that router physical interface, we create the sub interfaces to handle the different VLANs we have within the network that is connected to that interface. Okay, and then we set the encapsulation.1q with the VLAN ID, give it an IP address and a subnet mask so that it will handle traffic from that particular VLAN. So the sub interface for VLAN 10 will handle traffic from VLAN 10. Sub interface from VLAN 20 will handle traffic for VLAN 20. Okay, easy. Now let's look at how we are going to do inter-VLAN routing using a layer 3 switch. So as we said just now, this is something used by larger, like medium-sized to larger organization. Okay, So because layer 3 switches provide faster, a much more scalable method of providing inter-VLAN routing, so these larger size organization uses layer 3 switch inter-VLAN routing rather than route on a stack. Okay. So layer 3 switches use hardware-based switching to achieve higher packet processing rates than routers. So hardware-based switching faster than software-based switching. So a layer 3 switch has the following capability. It can route from one VLAN to another using multiple switch virtual interfaces. It can convert a layer 2 switch port to become a layer 3 interface. Now this is important when your network wants to talk to the internet, right? So that port, the one port on the switch, it has to now be a layer 3 interface because he's talking to a layer 3 device. Okay. To provide inter-VLAN routing, layer 3 switches uses SVIs. Okay, so SVIs are configured with the same interface VLAN ID command. You will see it in a little bit. Okay, so you must create a layer 3 SVI for each routable VLAN. So in this figure, D1 here is a layer 3 switch. Okay, it is connected to two devices that are in different VLAN. Okay, so when PC1 wants to connect to PC2, which is on different VLANs, D1 can provide that inter-VLAN routing without going out and asking for a router. So on D1, we have the VLAN interface here, G106 and G1/0/18 will be assigned to the VLANs and then be given an IP addresses for that. This is the step. So the normal step, first we have to create the VLAN and then assign the VLAN, okay? And then create the SVI VLAN interfaces. So the IP address of this interface will be the default gateway of the PC that is connected to. Okay, so for VLAN 10, this is the IP address that you will give at D1, and that is the IP address that is going to be used by PC1 as its default gateway. And then you're going to configure access ports. So assign appropriate port to the required VLAN, and then you have to enable routing because this is not a router by default. This is a layer 3 switch. So you have to say enable IP routing so that it can do routing work. Okay. This command must be configured to enable inter-VLAN routing on a layer 3 switch for IP version 4. So let's look at the steps. First, create the VLANs. Create VLAN 1. VLAN 10, give it a name. VLAN 20, give it a name. And this is done on the layer 3 switch. Then you assign an IP address. Remember, these are SVI, virtual interface on the switch. So it doesn't, if you see this, interface VLAN 10. We are calling that virtual interface an interface to VLAN 10. Okay, so this is the default gateway, and you give it an IP address and a subnet mask that is within the VLAN 10. No shut, don't forget this. And then do the same thing for VLAN 20 as well. So you see here, once you do the exit, it will say line protocol for interface VLAN 10 is up, and then line protocol 20 is up as well. So now you have to configure access ports. When you configure this SVI, this is virtual, right? It's not connected to anything. It's within that. But this is the interface that is connected to the device. So interface gigabit Ethernet 106 access port to PC1, switch port mode access, switch port access, LAN 10. So in this particular interface, it is an access switch because it's connecting to the PC. So this one's be access. And then this belongs to VLAN 10 because this PC is going to be in VLAN 10. And do the same thing for this interface for VLAN 20. Remember, the mode is access because it is being used by the PC. So in the inter-VLAN routing switch, it is simpler to configure. This is what
Doctor, I have a question.
Yeah.
Go back to the previous slide. If I put a layer 2 switch between the PC and the layer 3 switch, will the link between the layer 2 switch and layer 3 switch be trunk or access?
Well, the thing is, what do you want the layer 3 switch to do? Right? Excuse me. Remember, this is a switch, right? And it has a lot of interfaces. It doesn't have like 2, it can have like 24 or 48, depending on the size or the port density of the switch. Question is, why do you want to add another switch here? But if you do, then this switch will play the role of this particular link. If you put it into a switch, it will play the role of a trunk when it is going from VLAN 10 to VLAN 10. Let's say here you also have another switch, right? And then you have a VLAN 10 over there. Then that one will work as a trunk.
Okay.
But if you here in this one particular switch, but you have multiple VLANs in it, then you don't need, you understand? Let's say there are 48 interfaces on this switch, the layer 3 switch. You assign 10 to VLAN 10 and another 10 to VLAN 20. And then, so you have like 10 PCs on VLAN 10 and 10 PCs on VLAN 20. So the VLAN 10, it can just work like a switch, normal switch, but when it goes from VLAN 10 to VLAN 20, then it will do the routing, all within the same switch. Okay.
Yeah, I understand now.
Okay, thank you. Good. Okay, I'm moving on. Simple to configure, la 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 la. Okay, after that you can verify your configuration. So if VLANs are to be able to be reachable by other layer 3 devices, what it means here is that you have your VLAN. What VLAN just now? I forgot. We have our VLAN 10 and VLAN 20, but we want other people on the internet to be able to find you. So this particular switch will be connected to a router, right? So one port on that switch, you must make it into a routed port. Okay, you have to configure it as a routed port. So a routed port is created on layer 3 switch by disabling the switch port feature on the layer 2 port that is connected to another layer 3 device. What is Mrs. Zina talking about? I'll show you a picture. It gives you a better sense of it. Let's say we have this network. This part we saw just now, correct? This part is not a problem. Okay. But this network over here, if you want this PC to be able to connect to that server, for example, of course, that server and this router must be able to connect to these different VLANs as well. So this layer 3 switch has to have one interface that is connected directly to the router. Of course, a router, if it's going to do routing configuration or routing functions, this interface here, GZ1/0/1, must be a routed interface. Remember, this is layer 3 switch, so you can set it to be a routed interface. That way, it can get information, exchange routing information with the router, and then you can actually do routing to enable the PC1, PC2 from different VLANs to actually get to the server and use the server. Okay. Here, the router is using OSPF. Now, OSPF is a routing configuration, routing protocol. We have learned RAID version 2, we have learned EIGRP. OSPF is another way. I'm just going to show you the examples here, okay? But it would work if it's running EIGRP as well. So how do we set this thing? We have to configure the routed port, okay? So to configure a routed port on a layer 3 switch, we have to say no switch port. We are telling that particular port, that particular interface, you are not working like a switch anymore. You are going to work as a router, that particular thing. Okay, so we have to convert the port to a routed port and then assign an IP address and a subnet mask to it. Then enable the port. Okay. Then you have to set enable routing, use the IP routing global configuration command to enable routing. Remember, by default, the switch is working like a switch. It is a layer 3 switch. It has the capabilities, but it doesn't do that yet. You have to enable it. It's sort of like, the best analogy I can think about right now is like Superman. Okay, Superman is a reporter. He's a journalist, you know, with his glasses and so on. I know he does everything, but when he wants to become Superman, he has to enable it. He has to, like, you know, show the S on his chest and whatever, and then he can do his Superman work. So enabling it. So you have to enable that. And then you have to configure routing. If it wants to do routing, you have to configure routing on it. So in this example here, it is going to be configured with OSPF. Okay, I'll talk to you through that. Don't worry about it. And then, of course, you have to verify routing and verify connectivity. Now that this port has become routed port, it has a routing table. Okay, let's look at this. So remember, this is all in that layer 3 device. So configure the routed port. So we decided that the gigabit Ethernet 1/0/1 would be the routed port. Okay, so we give it a description and we say no switch port. Okay, you are not a switch port anymore. You are going to be a routed port, and we give it an IP address and a subnet mask. Okay, I'm just going to go back for a little bit. 10.10.10.2, okay? You see that? This is this network. This here on the router is 10.10.10.1, and this one here is 10.10.10.2. This network, this subnet over here for this link. Okay. So we set that, no shut, don't forget that, and then exit. So we have now configured this interface to be a routed port. Then we say IP routing, because we want to say, okay, you have to do some routing things in here. So we enable routing, and then we configure routing. So here it is using OSPF. So router OSPF 10, the network that it has, remember, this is from VLAN 10 network, this is VLAN 20 network, and this is the VLAN, oh, sorry, this is the network that is connected to the router, which is this network over here. So these are the networks that it will advertise. If I were to change this to EIGRP, it will be router EIGRP and then the autonomous system number, and then network, whatever network is. And 0000255 here, this is the wildcard mask. Yeah, I have to write some things down here for a bit. This here is the wildcard mask, okay? Because the network here is 192.168.10.0/24. So 24 bits would be 0, and the remaining 8 bits will be 1. So that's why you get 0.0.0.255. So this is basically 0.000000000. That's why you get 0.0.0.255 here. Now, if I were to change that, okay, into EIGRP, it would look something like this. Let me change the color. So it will be router EIGRP, so that you can understand better, EIGRP, and then the autonomous system number, whatever it is, and then network 192.168.10.0, network 192.168.20.0, and then network the 10.10.10.0, and then maybe we have to have no auto summary if you're using, you know, all that. So, but basically it's just the same thing. Only OSPF, the things that is extra in OSPF is that you have the number that everybody must match, you have the wildcard mask, and you have to have an area. And area, they must match as well. So this is what you call single area OSPF. In internet work, you will learn about OSPF, how to configure OSPF. But this is basically it. It's the same thing. Okay, so we configured that one. The button here we are configuring on the switch. So when we configure that, you would see that it has now, means that it has made an adjacency with the router. So it has made a neighbor, and now it can exchange information, routing information with the router neighbor just now. So after this, I'm going to stop this so the things are going to be missing. You can verify the routing. See here, this is the switch, the layer 3 switch. But because we have enabled routing on that particular interface, it now has a routing table. So these are all locally or directly connected information. But O is the one that it learned via OSPF. Where is the O? This thing is, okay, here you go. Oh, this O over here. Okay, O is because it learned via OSPF, and then that's the network. And then it learned this remote network via the router, and it has its own routing table. And then you can verify connectivity by trying to ping the server, and you see that, oh, it's fine. You can ping the server. You see that the PC2 also can ping the server. PC1 and PC2 are in the different VLANs connected to the layer 3 switch. Okay? So first, you have to create a VLAN to be, the mode access to the VLAN that you have. And then you have to create a virtual VLAN for the different VLANs that you have. And then those things can communicate between the same VLAN. If you want to communicate between different VLAN, then you have to set the layer 3 thing, it will work. But if you want to go outside to the internet, to the remote network, then you have to set routing capabilities on the, on the layer 3 switch, so that it can have connection, and then it will be able to connect to the remote networks outside of its own network. Okay, it's a bit of a twist because it's one device doing two things. Before this, you looked at switches. Switches only settle layer 2 things, so all MAC addresses easy. Then you look at routers, only handle layer 3 addresses, easy. But now you have a layer 3 switch, which has both. You have to look at it from different sides and different usages. Okay, as a switch and as a router. Okay, does take a little bit time to sort of like get everything down, but you'll have to. So troubleshooting inter-VLAN routing. There are a number of reasons why an inter-VLAN configuration may not work. All are related to connectivity issues. So first, check the physical layer to resolve any issues. What it means is basically this. Sometimes you configure ports 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to be in VLAN 10, and then you stick this VLAN 20 PC into this port. Of course, it's going to be in the wrong, physical link, so you just have to change that first. Always check physical connection first before you go on and check your configurations. So if the connections are correct, then use the list in the table for the common reasons why inter-VLAN connections may fail. Missing VLANs. So check whether or not we have missing VLANs. No, there's no VLAN 10, there's no VLAN 20, it was not created then. Set. And switch trunk port issues, access port issues. It's supposed to be a trunk, but it isn't access, or it's a trunk and then the things that is allowed on it is not allowed, for example, and it's supposed to be an access, but you set it to be a trunk and all that. So these are normal things that you can check. Also, router configuration issues where the sub-interface IP addresses is incorrectly configured. Hey, you use a wrong IP address of a wrong subnet, for example. Okay. Router and sub interface is assigned to the VLAN ID. Don't make a sub interface and then assign it to the wrong VLAN ID. For example, you make it for VLAN 10, but when you assign it to VLAN ID 100. Those simple things like that. Oh, my voice is gonna go. Excuse me. Okay, so here, this is the inter-VLAN routing, right? So let's troubleshoot this. We have the trunk links, we have seen this before, and okay, this is the IP addresses here and there, and we have the sub interfaces on the router, and it's sort of like matches here. Okay. So missing VLANs is basically, again, if you notice, we have seen this before, and it is assigned to a VLAN, but that VLAN is not there anymore because on the switch, that VLAN may have been deleted. So that particular VLAN is inactive. We have to reassign or recreate that VLAN. Okay, so here again, excuse me, VLAN 10 is accidentally deleted. Okay, and if you notice that VLAN, that the interface, which is interface fast Ethernet 06, see, VLAN 10 is not here. Fast Ethernet 06 is not here as well. It's just gone in the ether. It is inactive. So this is why you always have to reassign ports before you delete the VLAN. So you go recreate the VLAN and reassign it and then delete the VLAN, and then everything will be okay. Another issue for inter-VLAN routing includes misconfigured switch ports. Okay. However, with the most common is misconfigured trunk. So it's basically either it is an access, but you put it as a trunk, or it should be a trunk, but you put it as an access, or you forgot to do it altogether. Okay. So verify that the port connecting to the router is correctly configured as a trunk. So you show interface trunk, you can see all of the interfaces on the particular switch, which is a trunk. And then you can check whether it is, what is the native VLAN, because if the other side native VLAN is different, then we would have a problem. And what are the VLANs that is allowed on it? We can check that one as well. So if you want to check whether or not what type it is, you can also look at the interface switch port. You would see that fast Ethernet 06 is a access mode. It has been set to access. So if it is supposed to be a trunk, you can see it here. Okay. Oh, this is the example I told you before when you actually use the wrong sub interface. Here, when you configure, right? You configure it to be show interfaces, 01 protocol is up, encapsulation VLAN ID 1, .10 protocol is up, virtual LAN ID is 100. So if your interface is for port 10, are you supposing it to be connected to VLAN 10 or VLAN 100? You can check it here. Okay, so in this particular example, they have incorrectly set it to be 100 instead of 10. Of course, it's not going to work for devices in VLAN 10. So that is troubleshooting. There will be some labs on troubleshooting so that you can actually see these things that I have been talking about in your lab environment. Okay, so far, is there any questions about anything? While you're thinking about that, let's go through the summary. So today we looked at VLANs. Okay, we understand that VLAN is a logical grouping of a few devices in a group, and then they can have even though they are physically connected elsewhere, they can be in a logical group. Okay, so VLANs can be used to segment the network based on function, based on team, based on application. You know, your IT, your HR, your R&D, or student or stuff or whatever it is. And each VLAN is considered a separate logical network. And because it is a separate logical network, it only within that network is the broadcast domain. It doesn't broadcast outside of that VLAN. So we have, by using VLAN, cut down on the broadcast domains. And a trunk is a point-to-point link that carries more than one VLAN. So when you have this different physical location and you want the different VLANs or the same VLAN to talk, like there is devices on VLAN 10 at level 3, and there are devices of VLAN 10 at level 2, and you want them to talk together, so you need trunk so that it can move from that physical physical level 3 to physical level 2. So trunk can carry all VLAN, 10, 20, whatever, and it knows which VLAN needs to go where because all of these VLANs are tagged. So data VLANs, VLAN 10, 20, whatever, it is tagged with the VLAN ID. Of course, management VLANs are not tagged, and these are going to be taken under the native VLAN. A separate voice VLAN is required to support voice over IP because this separate voice VLAN will give it a higher priority, a better sort of like environment for it to work, you know, lesser delays, faster, higher bandwidth, you know, it can reroute out of like congested areas and so on. And normal range VLAN configurations are stored in the VLAN.dat file. So extended ones will be in the running config. So an access port can belong to one data VLAN at a time, but it can also be part of a voice VLAN. So it cannot be a member of two data VLANs. It can be one data VLAN and an addition of one voice VLAN. So a trunk is a link between two switches that carries traffics for all VLANs. And then the 802.1q, this is the protocol they use for tagging. Okay. And then we have the dynamic trunking protocol where we can set the port in the switch to be negotiable, but it is not advisable to do that. It is good for us to set whether it is trunk or it is access. DTP is used by Cisco, only on Cisco devices, for managing trunk negotiations. Okay, and these are some of the terms we saw today. And that is the end of the chapter. So is there any questions? All right. So since there are no questions, I am going to stop the class here today. Okay.